All right, we have one last family to look at, the quadratic function family. Over to the right, I have the parent, y equals x squared graphed. And then to the left, I have some family members. Let's see how the different values affect the parent graph. Let's look at our first one. Y equals the quantity x minus 2 squared. So what happened here? It was what? What did we do to the parent graph? We translated it 2 units to the right. So this is a translation 2 units right. All right, let's see the next one. Y equals x squared plus 3. This is a translation 3 units up. This is very similar to the absolute value ones. These values affect these like the absolute value ones. All right, so here's our next one. Y equals negative x squared minus 2. So you probably should be able to guess what the negative 2 is going to do. It's on the outside of what you're being squared. Up here, this plus 3, when it was on the outside, it moved it up. So the minus 2 is going to move it down. But what else did we add to the parent graph? This negative sign. What might the negative sign do? Let's see what happens. So, what did we do? We did a reflection, that negative sign, did a reflection over x-axis, and then the minus 2 translated it. It was a translation 2 units down. All right, we got 2 more graphs to look at. Y equals 3x squared and y equals 1/2 x. So let's look at y equals 3x. It made the graph skinnier. Let's see. That's what y equals 3x squared did. Let's graph y equals 1/2 x. Okay? It made it wider. So we see from these 2 graphs that when you write a number in front of the x squared term, it changes the size of it. So these both are dilations. It makes it wider or skinnier. So a recap of what we've seen. When you have an equation in the form y equals a times the quantity x minus h squared plus k, the k value moves it up or down. The h value moves it left or right. And the a value changes how wide it is, changes the width. But the a value, if a is negative, it flips it. It's a reflection. Over the x-axis.